All right, going to open up your practice exercise booklet to exercise 62. There is a brief review blurb at the top of the exercise for you, refreshing your memory, hopefully, on negative exponents. Okay, it's been a little while since we've looked at those. I don't think we've had to use them at all this year. Does everyone remember back to last year? Negative exponent means
I don't remember this at all.
reciprocal. Okay, so quick refresher. If you had an a, for instance, to the negative third power, that would be written 1 over a cubed. The negative just makes it a reciprocal. But if you had 1 over a to the negative third, that would make it a cubed, technically over 1 or just a cubed. Of course, if it were a 5, for instance, to the negative third power, that'd be 1 over 5 cubed, but you could actually figure that one out, couldn't you? 5 times 5 times 5, 125. So 1 over 125. All right, let's go and take a look at these together. And Chris was first. Chris, you're supposed to rewrite as a positive power. How did you rewrite 5 to the negative second?
1 over 5 squared.
1 over 5 squared, which would have a value of 1 over 25, but they were just looking for 1 over 5 squared. What about x to the negative second?
1 over x squared.
Good. 1 over x squared, b to the negative third.
1 over b cubed.
Good. 1 over b cubed, and then the last one.
1 over y to the fifth.
Good. 1 over y to the fifth. On the next row, 1 over 8 to the negative second could just be written
8 squared.
Good. 8 squared, which of course we know is 64, but they were looking for 8 squared. 1 over a to the negative third. I actually made the mistake of putting this on the board a moment ago. A cubed. Didn't realize that was in there. 1 over 10 to the negative fifth.
10 to the fifth.
Just becomes 10 to the fifth, which happens to be 100,000, but they weren't looking for that. And 1 over x to the negative second.
X squared.
Just becomes x squared. Very good. Bottom row going across, you were evaluating 5 to the negative second.
25.
I'm sorry?
25.
No. Are you perfect so far? What do we get?
1 over 25.
1 over 25. Remember, we first have to take the reciprocal 1 over 5 squared, so 1 over 25. Quentin, staying with you, 10 to the negative second.
1 over 100.
1 over 100. 8 to the negative third.
1 over 512.
1 over 512. And then 2 to the negative fifth.
1 over 32.
1 over 32. Excellent
Wonderful.
job. How many remember some of those? Obviously, the first two we should remember from like elementary school, but how many remember 8 cubed and 2 to the fifth from your algebra classes? Hopefully so. Been a little longer for you. Okay, you had a year off from math, but good. Questions at all on this? All right. I'm going to collect those from you. And if you want to go ahead and take out your notebooks, turn to the constructions section.
Yay.
And get out your compass, get out your straight edge. I almost said crisis averted, and then you dropped it and spilled water in your face. All right. Here, let me get that from you. Did we got just a little water here in Kendall's book?
Wow. Good
Sis,
job.
she's sis.
Sis. Throw it.
Bro, either.
All right. Calm yourselves, children. Construction section of your notebook. Construction number 9. Construction number 9. Bisecting a given arc. Construction number 9 is to bisect a given arc. So at the top of the new sheet of paper in the construction section, construction 9, and at the top of the page, also write bisecting a given arc. Bisecting a given arc. Now in a quiz or test, there would be an arc printed on the page for you. Here you're going to have to make your own arc, so if you would, down below where you wrote bisecting a given arc, open your compass, really any amount, put the point of the compass really anywhere and make any sized arc. You could even do a major arc if you wanted to. I'm going to do a minor arc just for sake of, for ease, because I'm lazy. But draw some arc with your compass. Again, you do have to use a compass because a curved line is not necessarily an arc. A portion of a circle is an arc. And for it to be a portion of a circle, it would need to be drawn with a compass. I suppose as an alternative, you could use the curved portion of your protractor. For those of you who have a semicircular protractor, I think all of you would. But it'd be better just to use your compass. All right, bisecting a given arc. Before we get into the construction here, we want to take time to discuss the proof, if you will. How do we know what we're about to do is going to work? Well, let's figure out what we should do. When have we talked about an arc being bisected?
With perpendiculars?
perpendiculars, perpendicular bisectors of
Congruent circles.
some chord, right? We said that if you have the perpendicular bisector of a chord, really if you just have the perpendicular to the chord from the center of a circle, but the perpendicular bisector of a chord will pass through the center of the circle, but the perpendicular bisector of a chord will also bisect the arcs, or in this case, arc, that chord cuts off. The problem is I don't have a chord. Draw one, right? 2 points determine a straight line, correct? And you have 2 points. So between the end points of the arc, if we simply connect those dots, I have a chord, which, if I construct the perpendicular bisector, will have to also bisect the chord, correct? So at the bottom of the page, or bottom third of the page, if you'll recall, it's been a while since we did constructions, but leave about 8 lines or so from the bottom. Step number 1 is to draw the chord joining the endpoints of the arc. Draw the chord joining the endpoints of the arc.
Say it again.
Draw the chord joining the endpoints of the arc. That's step 1. Step number 2, construct the perpendicular bisector of the chord. And in parentheses put C-1, capital C-1, because you're just going to do construction number 1. Most of these constructions we are doing use the 8 fundamental, or really the first 5 fundamental constructions that I taught you. So we're going to use that very first construction in this. Step number 2 is to construct the perpendicular bisector of the chord, and in parentheses C-1. From yesterday, you recall, to construct a perpendicular bisector class, you put the point of the compass on one endpoint, open the compass
More than half.
beyond the halfway mark, anywhere beyond the halfway mark, though, I mean, don't get crazy. And then you'll need to make an arc above and below. Then you'll need to keep the compass open the same amount, remember. Again, all of this is detailed in construction 1. Put the point of the compass at the other endpoint and make intersecting arcs. Again, the key is that the compass is open that same amount. Now, when you construct this perpendicular bisector, it should pass through the indent in your paper that the point of the compass left, shouldn't it? Since we said the perpendicular bisector of any chord will pass through the center, this is a good indicator that you constructed it correctly when your perpendicular bisector goes through the hole in the paper, or the indent. Raise your hand if your perpendicular bisector did indeed go through the indent like it should. Okay, a few of you. How many of it missed?
Barely.
All right, so if it missed, that means you're just barely off then, right? But yeah, and so right here is really the point in question. This point of intersection is what bisects the arc. Pretty straightforward construction, I would say. Okay. Turn the page over. We'll practice it one more time. Not that this is one that requires a whole lot of practice, but we'll do it anyway. And open up your compass some amount. I want you to make a major arc this time. Go ahead and make a major arc this time. Do an arc that is bigger than a semicircle. Make an arc that is bigger than a semicircle. And step number 1 is to do what, Quentin?
Draw a chord.
Draw the chord. From one end point to the other. Now, I have had students say, Mr. Dasky, is the chord absolutely necessary? Could I not just go to the endpoints here and make those arcs? Well, it's true, you could technically skip step 1, but there's a great reason to do step 1. Number 1, it allows you to know how big to open the compass, right? You can visually see the more than half a little bit better if you've got the line, but also, if your line comes out and it doesn't look like a perpendicular bisector, we can visualize that really well. So just helping us to be more accurate, helping us to visualize the accuracy, yeah, the line looks perpendicular, looks like it bisects the line, therefore it will also bisect the arc. It's just as an added help. All right, so once we've got our line, then we need to construct Audrey. Well, we don't construct Audrey. Audrey, we need to construct the perpendicular bisector. So as I mentioned a moment ago, we need to open the compass, put the point of the compass on one end of the chord. By the way, if you didn't open your compass any wider, where would the arcs go through, anyone?
The other side.
The center of the circle, right? If you had your compass open, you made the arc, and you left it the same, your arc would have to go through the center of the circle, wouldn't it? Not that it's a problem necessarily, but yeah, open the compass a little bit, make an arc above, arc below, then keep it the same amount, Audrey, go through and make those intersecting arcs. Now, one word of caution here with the major arc. I've seen this before, and it kills me. Did I bisect the arc, class?
Nope.
Nope, because the perpendicular bisector didn't go through the arc. Make sure, especially on the major arc, make sure when you construct your perpendicular bisector that you make it long enough that it bisects the actual arc itself, right? Otherwise, you've done all the steps, but you failed to do what you set out to do, right? And that would be a bummer. All right, questions on this? That's the only real word of caution, is especially on a major arc, where you may be inclined to forget that. Just make a mental note, make sure we draw the perpendicular bisector long enough that it actually hits the arc. Questions on this construction? All right, new page in your construction section. Next page in the construction section, top of a new sheet of paper, construction 10, C-10. Construct a line parallel to a given line through a given point. Construct a line parallel to a given line through a given point. Construct a line parallel to a given line through a given point. All right, once you have that down, go ahead and go maybe 4 or 5 lines down. Give yourself some room here. And go ahead and draw a line. Tell you what, draw it so it's not on a blue line. Draw it just a little bit slanty, so it's not actually on one of your blue lines. And then pick some random point up above that isn't on a blue line. So pick some random point that is not on a blue line on your paper. And we want to construct a parallel through this point, so something like this, parallel to this line here. That's the objective. Parallel. We're constructing a parallel. Well, whenever we saw parallel in a proof, what did we always think, class?
Equal angles.
Equal angles. So if I want to get a line parallel, I probably ought to have some
Angles.
equal angles. What kind of angles might be equal for me to get lines parallel? Alternate interior angles.
Corresponding.
Alternate exterior angles, corresponding angles. Good. All of these would work. But all of these angles are formed if and only if you have a transversal. Well, there's your first step. Step number 1 is to go down to the bottom, 8 rows up from the bottom, if you will. Step number 1, draw a transversal through the point and line. Draw a transversal through the point and line. Now, there's a lot of ways you can draw this transversal, right? The angle of the line doesn't matter. You could have a really acute angle like this. You could have a near perpendicular. You could have a more of an obtuse looking angle, though from this perspective it's acute. But it really doesn't matter. Just draw a transversal through the point and line. Now, the next step, there's actually several ways you could do this, but I'm going to give you the way that I feel is the easiest way, and that's with corresponding angles, which is what Ethan had said. Technically, any of the angles would work. I just find corresponding angles easiest because they're matching, right? And things that match tend to be easier to visualize. What we want to do then, class, is to take this angle right here, formed by transversal and line, and you realize if we copy this angle up here, I'll have a parallel, won't I? Because I'll have equal corresponding angles, therefore the lines must be parallel. So step number 2 is to copy the angle between the transversal and line above the point. Copy the angle between the transversal and line above the point. And then in parentheses, C-3, construction 3. Copy the angle between the transversal and line above the point.
It says C-3.
C-3, construction 3. So that way if you were studying, you're like, copy the angle. How do you copy the angle? Oh, Oh, construction 3, go back to construction 3. Oh, that's how you copy an angle, right? Hopefully you're not forgetting something this fundamental, but just in case. So remember to copy the angle. We're going to open up the compass some amount. Now, don't open it so that the compass would go beyond or at your point. We're going to open it within that. But also, here, do you see my compass fits between here and the point, but it doesn't fit on the transversal anymore. So we want to, when we open the compass, open it up some reasonable amount that would fit in both places, but not so tiny you can't work with it. And remember to copy an angle, put the point of the compass on the vertex, and make an arc through both sides. Once you've made that arc, got to keep the compass exactly the same amount, and make that same arc over there. So point of the compass at the vertex here, make the arc, then go to the point and make the same size arc. That's the first part of copying the angle. The second part, remember, is to measure across the angle. And I like to do it top down. Here's why. Watch. If I measure top down, I'm going to go top down here anyway. So if I go bottom up, then I got to flip it and go top down. So I like to measure top down. So I just keep the compass exactly as it is and measure top down. Ooh, I was actually slightly off on that initial measurement. There we go. So this line doesn't exist. It only looks like it does. All right? So you measure across, and then of course connect the dots. And as you connect the dots, you are drawing the parallel. And there we go. So you get your transversal, copy your angle, and as you connect the dots, oh, you don't have a sharp point anymore, so this compass is pretty much worthless to you. Why don't you try to get a new compass over the weekend? I will loan you one for now. Or if you have $2, I can sell you a new one, but just use this for now. Yeah, I was like, man, that doesn't look right at all. Yeah, you're kind of guessing there, so. An idea here.
Is there any more steps after 2?
So really, again, if we were connecting here, Jamie, it'd be more this point and that. Sure, something still seems just a nudge off there, but yeah, this will serve you better. I would go ahead and take it through the point as well, just to get the line kind of go for you there. Good. Okay, now Chris, remember what I said, when you open your compass, you don't want to open it bigger than the point, which you didn't, but you also need to be able to, when you open it this much, you need to be able to fit that up above the point as well, and you couldn't, so your transversal needs to be longer, okay? Looks pretty good. I would take it off the notebook and use it on the desktop and then just get back and forth there. All right, that looks really good, and that looks really good. So some of us had a little bit of a struggle with it. Turn the paper over, let's practice again. Turn the paper over and let's practice again. This time I want you to start with a line that is, I showed going uphill. I want you to go downhill, unless, I think, Ethan, you might have gone downhill last time. Go uphill this time. So go the opposite angle that you went, maybe a steeper angle. So I went a shallow uphill. I'm going to go kind of a steep downhill here with my initial line. And let's pick a point. Let's pick a point down toward the, let's go to the upper edge. Let's go to a point kind of here toward the upper end here. And first thing we need to do, class, to put a parallel through that point. Transversal. And I'm going to go this way this time. Go the opposite direction of what I did last time. Put your transversal there. And then we need to copy the angle, right? That's the key to parallel lines. How do I copy the angle? Kendall, start us off.
Put the point of the compass on the intersection starting point.
Good.
And we open the compass a reasonable amount.
Good. Now, would this be a reasonable amount, Kendall?
No.
No, it's not going to fit above this point, right? Now, I could either extend my transversal, or I could shrink the compass to where it's going to fit, right? One of the two. In my case, I'm going to shrink the compass because I'm kind of running out of room because I didn't plan too good. Yeah, so either open the compass a little bit less, close it up, or extend your parallel. Now, I've got two options, Kendall. I can either copy this angle, which is acute, or this angle, which is obtuse. Since my compass class is not open very far, it might be easier to do an obtuse because I get to open it a little bit wider, right? And the wider you open the compass, the more control you have. So because I had to keep my compass small, it would be easier to make the arc here on the obtuse side of things. Does that make sense? All right, so we make that arc, then we need to measure across. And again, make this little mark so that way you know for sure it's lined up correctly. Ooh, I just barely made that first arc long enough. And when you connect the dots, go and go all the way through the point. Don't stop at the point, go out from the point, go through the point. So there's my point of intersection, and there's my parallel. Let's see how we did on the second try. That looks pretty good.
I lost track of where we were at.
All right, so you start by measuring across the angle. And so here, ooh, just, yeah, see here, do you see your arc didn't hit the line? We need to be able to measure from about here, I think, to here. But it's kind of a guesstimate that I'm in the right spot. And then you'll just connect down there. Okay, so here's the problem. You're going on this side, make sure we stay on that side, because we're going corresponding, right? So if you stay on the left side, stay on the left side. That looks good. Where's the point and where's the line?
Mine's right here, point's right here.
Okay, so this is your point, this is your line, this is your transversal, right? So you came here, you make an arc. Come here, make an arc. Measure across. This arc you just made, and then come measure across this arc that you just made. And then this point and this point are what you're going to connect. Looks pretty good. Looks better than last time. Looks pretty good. Now there's another way you could do this construction, and I'm going to show it to you just as an option, okay? This method tends to be the quickest way, and I'm lazy, but there is another way. Go and draw a line. Pick a random point. Because when we think of parallel, we think of equal angles. But there are two terms that we tend to associate together, parallel and perpendicular. We realize two perpendiculars would make a parallel. For instance, if I'm facing here, going this way, and I were to go perpendicular, and then were to turn perpendicular to that, I'd be back where I was. Or I'd be facing the opposite way, but it'd still be parallel to where I was. Another option would be to do your Cyclops or Mike Wazowski construction. Open the compass a little bit beyond the line. Make your points of intersection. Give Mike/Cyclops a goatee. And construct a nice, tall perpendicular. That's construction 5. Then, construction 4 would do another perpendicular. Now you're noticing this takes a lot more steps. So this is why I don't recommend this method, but it will give you a parallel. So the option would be construction 5, then construction 4. And back-to-back perpendiculars will also give you parallel lines. For some of you, this may be easier, not quicker, but easier. So once you've got your perpendicular, now do construction for at the point. Point of the compass on the point, little mark above, little mark below. Open a little wider, come out here and make marks on the sides, and that could also give you a parallel. Does anyone think this method is easier? No. And again, it's more markings, more measurements than the other. The other is line, arc, arc, measure, measure, connect the dots. We're done. This is arc, 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 line, arc, 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 line. A little bit more steps to it.
I think it's like, it's more comprehensible, I guess, if that's the word.
Instead of, double perpendiculars maybe a little easier to wrap your brain around than the corresponding angles being equal. All right, it's an option for you. Okay, so I wanted to show it. It's not my preferred method, and because of what we're going to do in the future, you're going to have to know this method. Because there are times you can't use perpendiculars to get what you need to get. Okay, you've got to be able to get other parallels. But that method does work for just constructing a single parallel. Let's practice one more time. Get out another just trash sheet of paper, maybe just something else that isn't necessarily going to go in a notebook. Though I suppose if you've got room and you could do a third construction on the back here. Let's practice one more. One more time. Let's practice this construction. Let's start with a nearly vertical line this time. Start with a nearly vertical line. And let's see, should we go left or right, class?
Left.
Go left? All right. That's the way the country's going, so let's go left. And we're going to construct a parallel going down, like the country's going, off to the left of our given line. And the first thing that we would want to do here, Genesis.
We're doing I'll do the Michael Zowski.
Let's do it the other way, because we have to be able to do the other way. So start with a transversal. Now again, strategy tip here, folks, watch. When you draw your transversal, I don't need it to go through the line very far, okay? But I do need it to have plenty of room beyond the point. Does that make sense? Because I'm going to put an angle here. I need room to put an angle here. So I don't have to go very far through the line. Technically, I don't have to go all the way through it as long as you hit it. But you do need to give yourself a fair bit of space on the other side of that point. Questions on that first step? All right, now what? Ethan?
Copy the angle.
Copy the angle. Okay, so that means put the point of the compass.
On the point, the vertex or whatever.
Okay.
And draw what you want.
Good. Now, again, the bigger the better, right? So as big an arc as you can fit would be ideal. Because some of us are having trouble because our arcs are so small. So if you can fit a decent sized arc here and also here, that's ideal. If you can fit a decent sized arc in both spots, that's ideal. So we go to the intersection point, arc, go to the point, arc. Make a match. Again, they should both be on the same side of the transversal. So in this case, below right, or if you're going to do the obtuse angle for some reason, above left, right? But on the same side of the transversal. So arc, arc. Now what do we need to do, Jamie?
Now we need to measure the arcs.
Good, measure the arc. Start with the arc you know and measure it. And then copy that measurement. So measure, measure. So it's arc, arc, measure, measure. And then to finish, class, simply connect the dots. And again, don't go but just between the dots. First, you don't give yourself a line all the way through to get your parallel. Let me come around and take a look at how this one turned out. Looks good. Still finishing, still finishing, still finishing. Looks good. Still finishing, looks good. Somehow a tiny bit off. I think part of the problem here is it's a small enough little gap. Right here it's kind of hard. but you had plenty of room. I would get your compass all the way out here, because you have room to come all the way out there, right? So now as you measure, you've got a good bit of space. And almost would hit about the same point, right? I mean, pretty close. Oh,
That's what I was using.
just use the pen then for the other. Whoop. All right. That looks pretty good. Looks pretty good. Looks good. I think I already checked yours. Yes. All right. Questions on the parallel, because without the parallel, not going to be able to do the next one. So I want to make sure we've got a good handle on this. Do we feel like we got the idea? Again, transversal. From there, arc on the angle you know, arc from the point. Measure the angle you know, measure the arc you don't, connect the dots. Next section, next item in your notes. New page of your construction section. Again, it may help to take the page out of the notebook and put it in when you're done. Some of us are having trouble because we're trying to work with the page while it's still in the notebook. Maybe easier just to have the loose paper on the desk, do everything, and then put it back in the notebook here in just a second. That's your choice. Construction 11 is to divide a given line into any number of equal segments. Divide a given line into any number of equal segments. Divide a given line into any number of equal segments. Now let's think about this. We already know a way to divide a line into 2 equal segments, class.
Parallel, or the thing we just did.
Or
Perpendicular bisector, right? That gives you 2 equal segments. What if I wanted 4 equal segments?
two perpendicular.
Well, technically 3, right? Do the one perpendicular bisector and then perpendicularly bisect each side, right? What about 8 equal segments?
Just keep going.
Right, bisect each of those. It would take a while, but you get the idea, right? As long as it is a power of 2, you could do it. 2 segments, 4 segments, 8 segments, heaven forbid, 16 segments. You get the idea, right? But what about 3 or 5, 6, 7? We already know 8, 9, 10, 11, 12. What about any of the others, right? How do we get those? Well, obviously perpendicular bisectors aren't going to work for this, but let's think about what we've done before. Remember we had this idea of a whole bunch of parallel lines? And we said that if you had one transversal and it was cut into equal segments, then any other transversal would have to be cut into equal segments as well. That's the idea we're going to use here. We're going to turn the picture slightly. I want you to maybe leave just a couple of lines space and draw yourself a line that's about, let's go about 3 to 4 inches. So a decently long line. A 3 to 4 inch line somewhere in that neighborhood. A decently long line. We want to divide this line into, let's go easy, let's go 3 equal segments. Let's go 3 equal segments for this one. Well, the key then is to get a bunch of parallels that could divide another line into 3 equal segments and use those same parallels to chop up this one. Does that make sense? So here's what we're going to do. Step number 1, go down to the bottom of the page. Step number 1 is to draw a long line off one end point at an angle. Draw a long line off of one end point at an angle. Draw a long line coming off of one end point at an angle. Sort of like this. So the yellow line down below is my long line as it just comes off at some angle. And don't make the angle too shallow nor too steep. So just maybe 45-ish degrees, okay? So we don't want to approach 90, but we also don't want to approach like 10 or 20. Decent angle coming up, but it doesn't have to be exact science. Here's the deal. I want to mark off any 3 equal segments then on here. I don't have to divide the whole thing exactly into 3. I just need any 3 segments that are equal. So step number 2 is going to be to open your compass a reasonable amount. I'm going to explain what that means in a minute. Open your compass a reasonable amount and mark off the given number of segments open the compass a reasonable amount, and mark off the given number of segments on the new line. Open your compass a reasonable amount and mark off the given number of segments on the new line. Mark off the given number of segments on the new line.
Reasonable.
So reasonable. I'm trying to do 3 of them, right? Could I do 3 segments this big on this line?
Yes.
Yeah. It's really small though. That's going to be really hard to work with. Bigger is better, right? Could I do 3 of these on this line?
No.
No. But maybe I could fit 3 of these, right? So open the compass as big as you feel you can get away with, basically, right? Open your compass up a good bit, but a reasonable amount. Now, what if I get here and I'm like, oh no, my line's too short. It doesn't fit. Now mine does, but what if it didn't fit? You could always extend the line, couldn't you? So even if you guessed wrong and you're just a little bit off, you could always fix it, but I'm lazy, right? I don't want to do that. So I'm going to kind of guesstimate. I think I could fit 3 of these. Now, strategy tip. This isn't going to be in the notes, but it's a strategy tip for you. I've had students struggle remembering where they're at in this construction because there's a lot of markings in this one. I recommend perhaps numbering 1, 2, 3, and perhaps scribbling the excess off. I think if you'll do those things, it'll keep you from getting confused. This extra doesn't exist. You only think it does. It's absolutely meaningless, okay? And I'm also going to number these so I can refer to them as point 1, point 2, and point 3. Does that make sense? Okay, you're getting that. You don't have to do that to do the construction, but it's a recommendation to help you keep track of things. Step number 3 is to connect the end of the last segment with the free end of the given line. Connect the end of the last segment with the free end of the given line. Connect the end of the last segment with the free end of the given line. Now, the given line has 2 ends. One end is now occupied. The other end is free. This is the free end. The end of the last segment is right here. It's not down here. That's why we scribbled it off. That's one of the biggest mistakes students will make, because they'll come to the end of the actual line. Well, not if it's scribbled off. You won't make that mistake, right? That's why I advise you scribble it off. We want to go to the end of the last, in this case, 3rd segment, and connect it to the free end of the given line. Essentially, we just formed a triangle. That's not the purpose in doing it, but it happens to form a triangle.
Triangle.
All right?
I like triangles.
Now, what we want to do now, class, is we want to copy this angle here so that we get a parallel and another parallel. Because what we'll have then is 1, 2, 3 parallels that do cut off equal segments on one transversal. So they must cut off equal segments on the other transversal. Do you see how this is going to work? But it's got revolves around getting parallels. Well, this is my transversal. This is my first parallel. So what we want to do now, put the point of the compass here, and when you open it, again, don't go past the 2 point. Stay inside the 2 point, but make an arc, and make an arc. So we're going to copy this angle and making an arc here, then go to the 2 point, make an arc, go to the 1 point, make an arc. Arc, arc, arc.
And
Then measure, 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 right? That's the key to the parallel, right? It's arc, arc, measure, measure. Well, in this case, there's 3 of them, so it's arc, 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 measure, measure, measure. And then we're going to measure the angle, and then come to this arc, and go to this arc. Ooh, whoa, my compass slipped. Ah, slipped again. And then to finish the parallels, of course, you're going to connect back to the 2 point, which is why it's numbered, because there's arcs everywhere now. We're going to connect back to the 2 point and back to the 1 point. And I have 1, 2, 3 equal segments. So we make the arc, 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 measure, 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 connect down to the 2, connect down to the 1. There's my 3 parallels. The step, how we would write it out in the notes, since most of you are finished, is to construct lines parallel to this connector, put that in quotation marks. Remember, because step 3 it said connect the free end to the end of the last segment. So construct lines parallel to this connector, in quotation marks. Construct lines parallel to this connector at the ends of the other segments. At the ends of the other segments. Good. Good. Still finishing? That's okay. Good. Good. Okay. Construct lines parallel to this connector at the ends of the other segments. Once you have that down, turn the paper over. And draw a 5-inch line, if you would, if you have a ruler. If you don't, that's okay. But if you have a ruler, draw exactly a 5-inch line. And we want to divide this 5-inch line into 5 equal segments. All right, step number 1, class, is to draw a big long line coming off of one end point at some angle. It's up to you the extent of that angle. The longer the line, the better, because you can make bigger segments, and bigger is better. Step number 2.
Equal sides.
Good. Open the compass a reasonable amount. Now remember, you've got to fit 5 of these this time. Can I fit 5 of these? I don't think so. It might be too close. I bet I could do 5 of those. So you open your compass a reasonable amount and mark off 1, 2, 3, 4, 5. Now if you guess wrong, you can always extend the line. It's okay. Or if you just make your line enormous in the first place, that works too. Again, I'm going to scribble off the excess, and I'm going to number 1, 2, 3, 4, 5. All right, now what?
Connect from the last point down to the unoccupied end.
Good. From the free end to the 5 point, if you will. From the free end to the 5 point. And then everything else is just constructing a bunch of equal angles, so we get some lines that are all parallel. So it's going to be arc, 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 arc. I feel like a dog when somebody comes to the door. Anyway, and then measure. There we go. Measure, 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 measure.
Sorry, where did you get the arc from? How
You go down here. There's an angle that you formed at the bottom.
Yeah.
You make an arc, and you go to the 4, make an arc. Go to the 3, make an arc. Go to the 2, make an arc. Go to the 1, make an arc. Then you measure the only arc you know. These are all unknown arcs. Stay with me. Brecken, if you'll stay there, I need to talk to you after class. This is the only arc I know down here, so I'm going to measure that arc, and once I know it, mark that off and all the others. And then, play connect the dots. Down to the 4 point. Love connect the dots. Connect down to the 3 point. If only we could connect it from the 3 point. Ethan. All right.
Seriously. I think I did this wrong.
And then connect to the 1 point, which would be like a free throw, right? Anyway. And there we go. We've got our line. Now, if you wanted to, you could check and see, are all your segments exactly an inch? Now, again, your ruler probably is not wrong. So you can measure them all. For me, I did 6. Okay, I was a little off on that one there. This line sum, I didn't come quite perfectly parallel. And that one's just, yeah, so these 2 lines are a little bit off. The first 2 are good. Questions on this construction? All right, for homework this evening, you're going to practice on your own paper constructions 9, 10, and 11 one more time. So for construction 9, some arc, bisect it. Construction 10, give yourself some line, make a parallel to it through a point. For number 11, I want you to specifically use 4 segments. But don't perpendicular bisect, perpendicular bisect, perpendicular bisect. Okay, using this method, 4 equal segments of whatever line you choose. So for homework, constructions 9, 10, and 11, one time each, but use 4 parts, 4 equal segments for your construction 11 that you do. If you didn't have a chance to finish this in the notebook, finish it as well. So if you didn't get a chance to finish up this 5-inch line, 5 segments, do that as well for homework. We'll go over this again on Monday and progress into some other constructions as well. All right, you are dismissed.